Good afternoon, everyone. Thank you for jumping in to our webinar. We'll be starting here. We're probably going to get started a minute, maybe two after the hour, just to give everyone a chance to finish up their lunch or their meetings and be able to hop on. But we appreciate everybody for joining us. All right. I see more people are coming on in. Again, thank you everyone for joining. I think we can go ahead and get started. We've got a lot of great content to cover. I'm sure some more people will trickle into the webinar. But again, thank you for taking the time to join us and the Enola team here today to talk about UAF. Before we get started, just briefly, we'll go ahead and do a quick overview of who Enola is. My name is David Klotz. I am the Director of Federal Accounts at Enola Systems or Enola Technologies. Just tripped over my own words for a second. And I wanted to just say again how much we appreciate all of you for joining in. We will be taking a Q&A about 15 minutes off the back end of this for Q&A. If you would like to ask a question, we have a Q&A feature in Teams. It should be probably at the top of your screen. And it literally says Q&A. So I will be moderating the questions in there, and we will try and get to those at the end. So again, I'll go briefly over who Enola is and what we do, and then I will turn it over to Tim Anderson, our COO at Enola, and he will be guiding you through UAF, demystifying a unified architecture framework, and providing a really comprehensive overview of what UAF is and what it is not. And so that way everyone has a great understanding. And we look forward to hopefully many more conversations with all of you in the future on this topic. So Enola Technologies, if you don't know who we are or you haven't worked with us before, we are a leading training, coaching, and consulting firm, and we are dedicated to the rapid evolution of our clients within the digital world. Our services are directed primarily towards digital engineering and transformation and model-based systems engineering services. In addition, we also have expertise in enterprise architecture, various different frameworks within EA, as well as software architecture, database architecture, ontologies, and technical collaboration and server management. So even though Enola is agnostic, we do have a very strong presence and strong partnership with the folks from Dassault, and a lot of our tools and our trainings reflect that. But like I said, we are agnostic. We work with whatever our clients use and whatever tools they use, even though we do happen to have a lot of focus and emphasis and familiarity with the Cameo and Magic Draw suites. Our mission at Enola is to train, coach, and mentor your staff to be independently successful as quickly as possible. That is our goal. Our goal is to help upscale and upskill your teams so that way you and your teams can also outfox the competition. What does Enola do and what do we offer? We offer comprehensive solutions, engineering excellence. And the way that we do that is primarily through three paths. We offer unique training programs, both on-site and virtual, in the form of open enrollments, which we have typically monthly, and also through direct training courses. Additionally, we offer skill building workshops, and we also offer support services to help lift the sort of the floor on your team to help those novices and beginners match that of your intermediates and your experts, as well as staffing. If you have a critical need, you have a contract that dropped or a project, maybe somebody unfortunately had to take leave or leave your company at the last minute, and you've got hundreds of hours of work and modeling that needs to be taken care of, we can assist. We have an extremely deep and talented bench, and we are always adding to it. Um, and I'll make sure to send this out to everybody. And since I really want to get into the topic at hand at UAF, I'm just going to highlight just a few areas of detail on the three things I just mentioned. So in terms of training with Enola, you can see our menu of different courses that we offer on the left. We do have upcoming open enrollments if you are interested. We have great ones on MBSE model execution, querying magic draw models with structured expressions. Both of those are coming up in September. And the main one I want to emphasize, given today's topic, is Enterprise Architecture in the UAF. It is a 5-day training course. But it is, as you can see, from 8 to 4. So they are full day training courses, but you come away with extensive knowledge because UAF is an incredibly comprehensive framework of how to utilize UAF, especially within the Cameo and Magic Draw tool set. And this is up to version 1.2 of UAF. So highly recommend it. Just so you know, the price on that for an individual is $2,900. If you're with the government and you're coming up at the end of the year and you still have budget left over for training, I highly recommend call us or email us at sales@enola.com. And we will look forward to signing you up and getting you in that class and really upskilling you as it regards to UAF. Additionally, we offer skill workshops. We even offer one for the UAF. These are a little different in the fact that they focus on more hands-on work within what you're doing at your company. So we take from the more academic side, and our training does offer labs and hands-on materials, of course, but then we get very, very hands-on trying to work with you and your team more in depth on those topics in our workshops. And finally, support and staffing. Like I said, Enola offers support packages that are a number of monthly hours that you can utilize not only through our support and ticketing lines for like help desk style support, but also for MBSE guidance, model reviews, and best practices. So it's kind of like an a la carte at that point where we're offering you a block of hours for support and you can kind of choose what you need and how you need it. And our engineering team can be there to raise that floor for the rest of your team. So that way you get up and running even faster. All right. And there's our contact information. Like I said, everyone that's attending, I'll send a copy of this out afterwards. And we look forward to hearing from you. Without further ado, I will turn it over to Tim Anderson. Tim is over a decade of experience with MBSE, software engineering, and enterprise architecture. He is our COO, and he has taught UAF course a number of times, and will be walking you through demystifying UAF today. So, Tim, I will take it away.
Excellent. Thank you, David. Let me get my screen up. All right. Can everyone see and hear me?
Since they're on mute, I will say yes, I can see you, so I'll presume everyone else can. Please raise your hand if you can. Oh, there are the emojis. There we go. Thanks, everyone.
Thank you, everyone. And thank you, everyone, for joining. I really appreciate this. So we're going to cover Demystifying UAF. It's an introduction to enterprise architecture with UAF 1.2 specifically. So it's the current version of the unified architecture framework. We're going to be looking at two major things here in this little webinar. We're going to cover enterprise architecture, so give you guys an overview of what it is, what it's trying to achieve, and how that relates to MBSE and solution architectures. Because most people that are coming in to UAF and enterprise architecture, they're
Oh,
almost
Tim,
always yes.
real quick, we just got looks like Lewis is having trouble seeing the screen. Real quick in the chat, is there anyone else that can't see the presentation material? It may just be an individual problem. I just want to make sure. Okay. Lewis, sorry, it may just be reload. Thanks, Chuck. It may just be reload and come back in. Everyone else seems to be good. Okay. Lewis, I
Okay,
hope you can get that. Worst case scenario, please listen, and I'll make sure to send out everything afterwards as well as a recording.
excellent. Thank you, David. As I was saying, we're going to focus on what is enterprise architecture, especially in comparison to MBSE with solution architectures. What I was trying to talk about was that a lot of people that are coming into enterprise architecture and UAF in this case, they're coming from an MBSE background. Most people are introduced to a model-based approach in SysML, with the Cameo tool suite or Magic Draw, and they're kind of working their way up into the enterprise architecture. It's not common that people kind of start at that high level. So there is a connection between the two, and we're going to talk about that here in the first section. And we're going to talk about the best practices for how one can drive the other. Then we'll get into the actual UAF itself. So we'll cover some fundamentals of what it is, what it's trying to do, how it can allow us to get a functional enterprise architecture, a useful enterprise architecture. And then we're going to break down the grid itself. I'm sure if you guys have ever seen or heard of UAF, surely you've seen the grid at some point. You've got effectively a matrix of rows and columns where the views that you're trying to build are the intersections of those. We'll cover each one of the columns. Those are going to be our aspects. We'll cover each one of the rows, which are our viewpoints. And so you'll get a pretty complete picture of all of the different ways in which we can build out our enterprise architecture with the tools that are available. We're not going to go into very specific views within each of those, but you'll have a good understanding of how to build different views and what kind of content will go into each of those views. And then finally, we'll just close it off with a concept of fit for purpose views, which is kind of like a catch-all. It says we don't have a spot for it in the UAF grid. You can always build your own version of a UAF view using a fit for purpose view. So that's the plan for the webinar. So again, we're going to start with enterprise architecture. So what is an enterprise architecture? This is going to be a framework that's going to help us understand our business better. You think of modeling out a system with an MBSE model where we're capturing all the concerns that we have maybe from our stakeholders, and we're trying to understand the behavior and the structure of our system. It's the same idea, just for the enterprise, for our business as a whole, or maybe even a chunk of the business or the enterprise. The sizing here is variable. But we're looking to strategize. As we're capturing the needs of our business, we're going to strategize on our goals. We're going to look at the business processes that our enterprise is going to follow. Those are going to help us achieve different capabilities within our enterprise. We'll talk about the personnel, so the HR concerns, the organizations, the positions that we have, the individuals filling those. System resources, technological resources that we can utilize to, again, exhibit capabilities. You'll hear that a lot as we're going through exhibiting capabilities and these ideas of resources. We have projects that the enterprise is currently undergoing. Those could be designing new systems, deploying systems, maintaining systems. It can be any kind of task that we're achieving within the enterprise. And we can talk about security concerns as well. So risks are going to become a factor as well. So a lot of different things that we're going to look at. It's all bundled into this one big old conglomerate called an enterprise architecture. We're often going to define these in model-based applications. Again, that model-based approach. Magic Draw Cameo being a common one that's very popular in the industry. And that's to visualize this and to make sure that we're properly understanding what we're trying to achieve. We capture what it is, our goals, what our goals are driving us towards, and then how do we get to that point. Often these are captured they can be captured in a number of different frameworks. It's not just UAF. UAF is currently the industry standard, if you will. It's the most common one that people are tending to flock to nowadays. But in the past, we've had DODAF. There's other ones like MODAF, NAF, TOGAF, the Zachman framework, the list goes on and on. So these aren't anything new. These have been around for a very, very long time. UAF is just the new approach for capturing all of these different concerns. Now, enterprise architectures, again, are defining our enterprise as a whole. And within that enterprise, you're going to have a different set of stakeholders for different concerns within your enterprise. Each stakeholder is going to have their own concern. They're going to focus on one piece of the giant puzzle that is the enterprise. You'll have people that care about the data that's being stored. You'll have people that care about the systems that are being integrated. You'll have people that are concerned about your human resources, HR, acquisitions, strategy, portfolio managers. There's so many different kinds of stakeholders that really make up an enterprise. Each one's going to care about a different piece of that larger enterprise. And what UAF is going to allow us to do is it's going to allow us to capture each one of those different concerns in different locations, keeping things nice and tidy, nice and organized, but making sure that we are not missing anyone. Make sure we're gathering all of that relevant information so we can see all those pieces together in one solid vision. So that the enterprise architecture is going to be the model that captures all of these different concerns. Now, how does this relate to a solution architecture? Solution architecture being something we develop using MBSE. MBSE is model-based systems engineering, and MBSE is really all about developing a system or some new technology. MBSE allows us to design, implement, test, and eventually deploy some resource, whether it's software, system, whatever. And when we look at that compared to the enterprise architecture is really the big picture. It's the entire business that is deploying numerous solution architectures, numerous resources. And so your MBSE models that you guys have been building in SysML, if you have, those are very narrow. I mean, they may be big models, but in the grand scheme of things, as far as the enterprise is concerned, it's a very narrow focus of that enterprise. So the enterprise is going to contain all of these other solution architectures. And as we're designing and developing and building these new solutions, they become realized resources at that enterprise level. That's the ultimate goal. We plan out what we need, design, develop, and build the MBSE model, and eventually that resource is deployed. And now it's an existing resource that is available to our enterprise architecture. So that's how the two things kind of coincide. So if you're thinking of MBSE, it is small. It's going to be, as you see over on the right and at the bottom here, it's going to be individual pieces of technology, individual resources that are deployed and used by that greater enterprise, which in this case, in this example, is that restaurant in the top left corner. That's the entirety of our business. And so that's how the two kind of work together. One is much more narrow, but again, very common. The other one is much more broad, and it's a living architecture where the solution architecture is really a design to solve a problem. Enterprise architecture generally is living. It's meant to expand as the enterprise expands, and it grows with the enterprise. We're going to make decisions and continue to update that enterprise over and over as long as we're following this particular process. So what does that look like? How does MBSE really function in the larger enterprise architecture vision? Well, we start by first understanding what are the goals of that enterprise. So what are we trying to do? What are we trying to achieve? And those goals are driven by a number of different factors. And we'll have a section in UAF to capture those different factors. But all in all, what are we trying to do? And eventually, once we have established what the goals of our enterprise are, we will realize that there's certain capabilities that we can then achieve given that we've reached those different goals. And those capabilities really are going to drive everything that we have within our enterprise architecture. Capability is the means of achieving a certain desired outcome, some desired effect. Now, once we have an understanding of what those capabilities are that we intend to achieve or that we can achieve, next thing we're going to do is we're going to capture any business processes that we need to implement in order to meet those particular goals. So what do we got to do in order to get or achieve that goal that we've now set out for ourselves? Now, this process of defining our business process will also give us a high-level architecture, a logical or a conceptual architecture of our enterprise. It'll give us key performance parameters, other constraints that we can apply to our enterprise, a lot of good stuff that we can then derive high-level requirements from. So this is going to tell us all of these are the things that we need to achieve a capability, and that's going to be your starting point that you're going to drive down to your MBSE team. That's going to be your initial set of stakeholder needs that you'll get in your MBSE world. Now, it's not only those, it's not only driven by this, but this is how it informs those starting points for your MBSE initiative. Then your MBSE team will go off and build their resource architecture, their solution architecture. Hopefully it's conforming to what the greater goals of the enterprise are, if they're following those requirements. And eventually, when they're done designing, they'll develop, implement, and deploy that resource into the greater architecture, into the enterprise. And then in the architecture, we will reflect that it's now deployed. Now it's an available resource. It's not just one that we're designing and intending to build. And given that it is now a resource that has been deployed, it's already achieving those capabilities. And so we can show that. We now have this ability to do some new desired effect. So that's the flow that you're going to see as we're going through our enterprise architecture. And that kind of story of walking through the enterprise architecture is going to come up again and again. And we'll see in the framework itself, it's built in that form as well. So that's an overview of our enterprise architecture, and again, how it relates to our solution architectures, our MBSE side. Now we're going to focus on the framework and the language itself, which is UAF. UAF is the Unified Architecture Framework, and it's managed by the OMG, similar to SysML, UML, BPMN, all these other languages you've likely heard of when you're doing your modeling. They're all managed by the Object Management Group, the OMG. And UAF is just another one of those standards. Now, when people refer to UAF, they're generally talking about one of two different concepts because they kind of get mixed together. There's the UAF grid, which is just properly UAF. It's the framework itself. And the grid is something we'll see in a slide or two, which is showing us the, again, rows and columns, and wherever they meet, that's the type of view that you want to create. The grid tells us the structure of the larger model of the repository, because we'll build our model in the same fashion as our framework. And it'll also tell us the kind of artifacts that we'll want to create in each of those different locations. So if you want to think of a synonym to this, it's kind of like Magic Grid, if you're familiar with that on the Cameo SysML side. So the Magic Grid framework does something similar where it defines those artifacts and the location of those artifacts. And then you have the UAF-ML, which again, if you pull up the OMG site, you'll see both of these two things. The UAF-ML is the UAF modeling language, so it's the ML. This is going to be the specification that tells you what kinds of objects you can create. What are my nodes? What are my relationships? What are the diagrams, the different views that we can create? And it details all that, and of course the constraints and all the other fun stuff that you can define for your language. And this is what's going to help us capture the enterprise architecture within the UAF grid. This is like SysML, UML. It's the same thing as the other languages. This is the proper thing that you're probably thinking about when you're thinking, oh, I'm looking at the UAF profile. You're looking at the UAF ML, the modeling language. But the grid is going to be our location where things go. And for both of these, the current version is 1.2. The 1.3, I believe, is in beta, and so we'll see a 1.3 probably pretty soon. But for now, we're sitting at 1.2. On the right here, you'll see this is what that grid is. This is what it looks like. You've got your rows, in this case, the yellowish architecture management, then strategic, so on and so forth. Those rows represent different domains within our enterprise. We call those viewpoints, and they represent the different stakeholder concerns. So if we're looking at, again, like a portfolio manager or some, acquisitions, we're looking at maybe the strategic high level view. If we're looking at our HR director, they're looking at the personnel view. Systems integrator, an IT admin, maybe looking at the resources domain or the actual resources. Like, it depends on what kind of person we are. We're going to have a different concern. We're going to focus on a different section of this architecture. And it makes it really nice to be able to just take a slice of this entire framework and see those concerns from a different lens, a different point of view, a different concern. So those are the rows of our framework. The columns of the framework are the different kinds of models that we can create, or different kind of diagrams is probably a little bit more apt. So motivation, taxonomy, structure, connectivity, all these columns that you see here at the top of the grid define what kinds of views we're looking at, not the content within them, those are the rows, but the types of diagrams that we have access to. We call these aspects in version 1.2. So a column in the UAF grid is an aspect. It defines the kind of diagram that we can define within that particular column. And then the rows define the content that's going to populate that diagram. And the cool thing about this is that when we break down the grid in this way, the columns, if you learn how to build each of the types of views in the columns, you can build all of UAF because you now have the knowledge of how to build the general forms of each of these different views. And instead of seeing, because there's like over 100 combinations within this grid, it's huge. If you're looking at just the columns, there's only 11 of them. We can look at all of them, we can read what they are and understand what they are. And so instead of having to learn hundreds of them, we just have to learn that small subset. And then the whole only hard part is now understanding which viewpoint are we currently in, what kind of content goes in them. And for most of those, it's pretty intuitive. UAF does a pretty good job of keeping a consistent terminology throughout the different viewpoints. So for the most part, once you've got a good handle on what it's trying to do, a lot of it can become a lot more intuitive. And so if you break it down in this way, it becomes a lot less scary to walk through UAF, because I certainly that was definitely a sticking point for me learning UAF when I first did. I was concerned, I'm used to SysML where there's only 9 views. Now there's 100 different views. How am I possibly going to learn them all? They do a very good job of making it as easy as possible. So you have maximum flexibility, but minimal learning needed to do so. One other term just to note, when we're looking at the cross section of an aspect and a viewpoint, so the row and the column, that cell is called a view specification. And you can look at the grid here. A lot of these view specifications are filled in as a single cell. Some of those cells are merged, and so some of these kind of span across different viewpoints, and they can be defined at any level of a viewpoint. Some of these are just blacked out. All those little black squares would be view specifications that the standard just doesn't give you elements for. Most of that is intentional, like the sequences of a standard. Standards are just like a named document, so it doesn't really make a whole lot of sense, and so they don't bother to give you a spot for it. That doesn't mean you can't create one, right? And we'll talk about the fit for purpose views a little bit later, but that opening, that hole, is there just because it's not in the specification. But that doesn't mean it can't. If you wanted to add it, you have that flexibility. And that's the beauty of this framework. For each one of these view specifications, each one of these cells, it gets even better. It's not just a single type of view you can create in there. For a lot of these, it's multiple. Some of these individual cells can have upwards of 6 different diagrams that could be created, distinct types of diagrams that can be created within them. Again, it is intimidating. I understand that. But once you get an understanding of the types of views you can create, it's really not that bad. So we're going to go ahead and keep moving forward in this, but that is what the grid looks like, and we're going to be using these terms as we keep moving forward. Now, UAF, it's stacked in the grid. So you start at the top with the architecture management, then strategic, then operational. It is necessarily in an order because it has to be. It's a 2-dimensional array. But it doesn't necessarily flow from top to bottom precisely. There are some overlaps, and there are some of those rows that really are at the same height if we're thinking about this in an objective way. And this graphic here on the right really represents exactly what I mean by that. At the top here is the strategic viewpoint. The strategic viewpoint, again, this is where we capture the goals of our enterprise. What are we trying to achieve? That's above all. What are we doing if we're not trying to strive towards solving the goals of our enterprise? So that's numero uno. Then we go down to the operational viewpoint where we're defining those business processes. That's the next step down. It's informed by the strategic goals, and now we're going one level lower. Below the operational, we have the actual resources. These are the ways in which we will solve those operational concerns. Resources or personnel. So it's either a technological solve or it's a human solve. One of the two. Either humans doing the problem or a piece of technology or some combination of the two. So that's why they kind of sit at the same height. a person doing a task versus a piece of technology doing a task, in the grand scheme of things, is equivalent. There's just different metrics maybe that show how one is more efficient than the other. So that they sit at the same height, right below the operational level. Security and services flank those two sides because they have concerns at both levels. Services allow us to identify provided required specifications for interfacing, either at the operational level for conducting the processes or at the personnel resource levels for integrations. Security, it's all about risks. We have operational risks, we have resource risks, security risks, and so we can capture those at either level. Then at the very bottom, we have actual resources, and then finally projects. Actual resources is going to be our already deployed, real, no kidding systems out there in the field, whereas projects are the things that we're doing. So what are we trying to do? We're either managing those active resources or we're designing and developing new ones. That's going to be at the bottom because those are real life tasks and projects that we're executing and eventually going to complete as we keep going through. So that's the flow from top to bottom. And then you have those giant pillars flanking the whole of that framework. We have architecture management, summary and overview, and then finally standards. Architecture management and the summary and overview are the high level views, just describing what it is we're trying to achieve with our enterprise architecture. And then the standards can help us at any level. We have standards that can apply to any object that we have within that larger framework. And so that's why you're kind of seeing it the way that it's laid out like this. So it's a really, really nice view, right, to see how these things really relate to each other when we're not locked into an actual grid. But the grid you'll see flows pretty closely to this, other than the projects and the actual resources kind of being flipped. All right, last bit of fundamentals before we actually get to hop into and see the aspects and the viewpoints. And we'll see examples of the different types of views that we can create once we get to those. This is a walkthrough of the actual process itself. As I mentioned before, we're trying to establish new things that our enterprise can achieve, or even just modernize existing things that we can achieve. Those are two very common scenarios within an enterprise architecture. And the concerns for achieving those capabilities are going to cross between the different viewpoints. A system resource, this bottom element that we have here, the order taker 3000, is going to be a real resource that we're developing or have already developed within our architecture. That is performing a function, a system function called process order and send to POS. That function will implement a business process, in this case, take order. That business process will map back to a capability, which tells us that it's what's needed to achieve that capability. And that capability, in this case, automated order taking, now has that full traceability. So by deploying our order taker 3000, we are claiming we have the ability now to take orders automatically. That's the flow that we have. Now, usually it's done from the top down. If we are strategizing and we're developing our goals and understanding what the enterprise wants to achieve, that's that top layer. I want to, as a restaurant, I want to be able to take an order automatically. I don't want to have any worry about humans in the loop. I want just an automated order taking capability. That's going to be the first step. Then we're going to define, okay, what's the business process that gets us there? It's this take order business process. Okay, now the next step down is where we can kind of fan out and see many different solutions. We could have this order taker 3000 take an order. We could have some drone take an order. We could have, the Terminator come in and take an order. Who knows? All these different things can come in and take an order, and they'll all do it in different ways. There'll be different metrics, different costs, different sizes. All the different key performance parameters will play into effect here, and we'll do trade studies. And we'll do tests to see, okay, which configuration is the best one for my enterprise, at least at this moment in time, because it could change in the future. That's the story here within the enterprise. This is the really, when you break it all down, this is one single thread of our larger enterprise architecture story, and this is what we're going to see over and over and over again. Everything else that we're going to see throughout UAF is going to build towards this story in UAF. So that's, as we keep going through, keep that in mind. We have our goals and capabilities at the high level, our business processes that are going to achieve those, and then the solutions that implement those business processes. All right, now we'll get into the fun stuff. So we're going to start with walking through the columns of UAF. And again, we'll provide examples and definitions for what each of those columns are trying to achieve. And then we'll get to the rows afterwards. So again, grid is made up of a number of different columns. We call these aspects. And the first one is the motivation aspect. This is a new one for version 1.2. The older version of UAF didn't have this, but I'm glad it got added. It's a very good one. The motivation aspect is all about capturing the motivation of a particular viewpoint. So why are we doing, um, you know, what's driving the content within that particular viewpoint? That's what we're trying to see here. So for strategic motivation, it could be things like drivers and opportunities that we're establishing at a very high level for our enterprise that's kind of driving the goals that we're trying to achieve, maybe challenges that we might face while we're going about that. For most of the other views, though, it's not going to be drivers and challenges, it's going to be requirements. And so this is motivation is generally your requirements view, though it is again, they broadened it to be more than just requirements. But that's why you see there's a big chunk of requirements right there in the middle from operational down to resources. It kind of merges. It's because it's all about the requirements that drive the content within each of those respective viewpoints. And that being said, the motivation aspect is generally going to be captured in your requirements type views. And so again, if you're familiar with SysML, that's going to be a requirements diagram. And in fact, in UAF, it literally uses requirements diagrams. We're going to see a lot of that. UAF borrows from SysML heavily. And so there'll be a lot of consistent things where if you know SysML, you already know how to do it in UAF. It's just given to you. This is one of those cases. So we have the requirements diagram, can capture our key requirements for that particular viewpoint and the traces to the relationships to other elements within that viewpoint. We can show a breakdown. In this case, we're showing the breakdown of the system requirements at the resource level. We can show derivations of requirements to other requirements, refining requirements, satisfying requirements, all that fun stuff. Rationale can be captured in this diagram. It's quite literally the same kind of view as we would have in SysML. So whatever you could do in SysML, you could do here. And it's the same elements on top of that. So you can see here we got like physical requirements, performance requirements, functional requirements. That's the SysML library. It's not a different thing in UML. It's literally the same object kind. So you get to reuse those. And so if you have them in an MBSE model, you actually could bring them up to the enterprise architecture level if that makes sense, because they are the same objects. So that's what it looks like here in the motivation view in the requirements section. Then we have a requirements table. Again, just like we had in SysML, we can see the requirements content in a diagram view, or we can see it in a tabular view. Personally, I've never been a big fan of requirements diagrams. I'm always against diagrams. So for me, it's almost always going to be a table. There's very few exceptions for where I'll break out a requirements diagram. But requirements tables, super flexible. They grow. They scale. You can show whatever information you like, including derived information with Cameo, which is really, really nice. So you can build your own custom columns if you would like. But the requirements table gives you that view. And it also shows containment. You can see in here like the SR4 payment acceptance in row 5 there. It decomposes, right? There's sub requirements to those. And so they can kind of cascade within the table, which is really nice. So this is the view I'll tend to build in this aspect, but again, you got flexibility, the diagram or the table. And then we also have matrices. Again, it's the same thing over and over again. This is the same kind of SysML requirements matrix that we have in your SysML models. And so you have the derive matrix, the satisfy matrix, refine matrix, verify. They still exist here. You can create them here as well. This is same thing, tracing the elements of this viewpoint back to those requirements, whether they're satisfying. In this case, it's a satisfy relationship or a derive relationship to other requirements, or a refine or a verify relationship. Those same ones exist here, and we're using the same rules as we did in SysML. So that's all still available here, still visible to us here within UAF. And that's the motivation aspect. So it's all about capturing the thing that's going to drive us forward for one particular viewpoint. Remember, this is still kind of general. We're looking at across multiple viewpoints, but the motivation drives us to find and develop the rest of that viewpoint. All right, that moves us into the taxonomy aspect. These next three aspects are very closely related to each other. They're all going to be a block definition diagram type of view, a BDD in SysML. So they're all structural, every one of them, and they're just mostly going to focus on a particular relationship that you can track within a standard BDD. If you recall in SysML, we can track things like generalization relationships, compositions, aggregations. In SysML, you're just given one view to do that. In UAF, they recognize that it's beneficial to have a view that's fully devoted to taxonomies, generalization relationships, versus a view that's wholly focused on decomposition of the structure. And so it's the same kind of view, same kind of diagram that is, but we split them into two different columns. So taxonomy and structure. That doesn't mean that you are prohibited from including a composition relationship on the taxonomy view, and you're not prohibited from including a generalization on the structure view. Nothing going to prevent you from doing that. It's like I said, it bleeds in either way. But the focus, the purpose of that view should be, at least in the taxonomy case, focused on that structure or that inheritance. So you're using generalizations primarily, and it's focused on showing you the types of things. And then we'll see the structure here in just a second. So the taxonomy, all about generalization relationships. And we have two different views in here as well, just like we did for the motivation. We've got the taxonomy diagram, which again is just a type of BDD, just like you'd have in SysML. This one is going to be specific to the different viewpoints. So you'll have a resources taxonomy or an operational taxonomy or a strategic taxonomy. It'll change. So you'll have different types of views. But under the hood, they're all the same kind of view. It's all a BDD or a class-based diagram if you're familiar with UML. The objects that go on it obviously are going to be dictated by the domain that we're currently looking at, the viewpoint, the row in the UF grid, but the relationship should primarily be generalization. And this just shows us types of things. In this case, we have an application as our most general kind. Game app, ordering app, payment app, notification app are all types of applications. As we go down, we get more specific. And then backgammon, chess, mahjong, solitaire, all types of games. And then we have a bunch of different apps for our ordering apps. So they get more and more specific as we continue to go down that tree. That's the idea with the taxonomy diagram. We also have a tabular version of this, just like we kind of did with the requirements. The tabular view here is less focused on the taxonomy, which is a little weird in my opinion, but it is. And it's more focused on the descriptions. So in here, we're going to see the name of the objects. We can show if they're abstract. We can, add if it's got a generalization. We can still show that. It's still a table like it is in like any other table in Cameo. So we can have flexibility on what columns we show. But we're going to focus on the name, the definition of that object, and then there's an extra field called a URI, which is it's a link effectively. It's a link that will uniquely identify this object. It doesn't have to go to a particular website. Like this case, it's got like Board Game Geek as an example for pointing to what does it mean to be backgammon. This could tie to repositories or elements elsewhere, but it's a way of uniquely identifying a particular object. This is something to do with ontologies, if you're familiar with the concept. So we are very specifically moving away from just the name of backgammon and saying this is the concrete definition of this object, and so this is the location. You don't have to fill that in, but just a nice benefit to include if you want to or if you need to. So that's our taxonomy aspect. Next is our structure aspect. The structure aspect allows us to track compositions or breakdown of structure. It's just another BDD view. So we'll show how an element within one viewpoint is decomposed into its children, whether they be parts or references. We don't really have that distinction here in UAF like we do in SysML. We just have what we call roles as we go lower and lower. So the order taker 3000 has 4 internal roles: the power source, casing, processor, and looks like 0 touchscreen. We'll have to clean that up a bit. And then the order taker 3000 has 2 roles that are external, which are their order tracker and our point of sale system. So internal and external, we don't have different types like we do in SysML. They're just all called roles here. But that's the structure. This one is probably the easiest one of all of them if you've done SysML. It's just a breakdown view. It's your typical standard BDD. Next is the connectivity aspect. This is all about the interconnections to your elements. Again, we're focusing on the resource examples here, just because that's the most complete viewpoint that we have in UAF. But this could be connectivity between operational nodes. It could be connectivity between different capabilities. It could be connectivity between different security enclaves. It just depends on the viewpoint that we're looking at. And for the connectivity, we're given two different types of views. We can build a BDD where it's capturing the different types of interfaces and their relevant exchanges. So surely you've built these types of views in SysML where you're identifying what those interfaces are and what they can be, what we can send across those interfaces. And then we move into the actual IBD, the internal block diagram, which is our internal connectivity. So here we are decomposing one of those objects, one of those structural nodes that we have from the structure aspect, and then we're seeing inside of it. So we get to see all the different roles that we have established for that object, the connectors that connect those roles to each other, and then the exchanges that they have. So this is just going to describe all the messages that can be passed back and forth between them, with the idea of being that those messages help to facilitate the achieving of different capabilities. So we're focused on the important communication in this case. We don't have to track every little thing that can be sent. We're focused on the things that are going to get us to new capabilities or to the existing capabilities. So that's our internal connectivity. We get one extra bonus view, which is our connectivity table. This is an ICD. So if you've ever done like a white box ICD table in Magic Draw, that's effectively what this is. It allows us to take a larger look at all of the things that can exchange that we're tracking on those internal connectivity diagrams. We can have many internal connectivity diagrams. Each structural node that we have within our architecture could have its own internal view where we're seeing those exchanges. This kind of looks across all those and says, okay, for the elements that you've established within your enterprise, here are all of the messages that they can exchange. And we get to look at the relevant metrics associated with those message exchanges. What are they exchanging? Who is sending what to whom? What functions are producing those objects or consuming those objects? And then we can get things like availability, timeliness, classification, all these other metrics that go along with those exchanges can be tracked as well. Next, we have the processes aspect. This is going to be for capturing our first look at behavior within the viewpoints. The processes, you might surmise, is our activity view. It's our workflow view. So we have two different types of diagrams for this one. There's a structural view where we can show how the activities within that viewpoint are structurally decomposed into their smaller parts. We can show taxonomy in this case as well. That's another option. So types of activities can be shown in this view, or we can show decomposition. In this case, conduct order is composed of collecting an order and delivering, displaying the order, inputting order details, so on and so forth. This lets us kind of take a step back and look above the flow. Because if you think about an activity diagram, you're looking pretty narrowly at one flow. With the structural view, we can kind of look above and look at how all of the different functions work with each other. Then, of course, we have the flow diagram. The flow diagram is the activity model. And there's no difference here. It's the same kind of activity diagram that we have in SysML. In fact, it works the same. The only new thing here is the color coding. So there's nothing extra here in UAF for these process flow diagrams. It's just your activity model for one particular activity that you want to decompose. The next of our behaviors is the states. This is your state machine diagram. Again, borrowed directly from SysML. Nothing new here. Once you know how to build a state machine in SysML, you can do it here in UAF. It shows the states a particular node can be in, and given that it's in a certain state, we can track what are the behaviors you can perform, and then what are the triggers, the events that are going to kick you out of that state and move you to something else, so we can respond to different stimuli. That's what the state machine diagram is all about. Where are we going? How do we get there? And what can we do when we get there? Next is the sequences aspect. This is all about message exchanging. Again, this one goes hand in hand with the connectivity view. Where the connectivity view was a static look at all the messages that could be exchanged, the sequences aspect is all about the timing and the ordering of those exchanges. This is a sequence diagram, hence the name. With the sequence diagram, we can show who or what are participating. Those are our lifelines, the columns that you see here on this view. And then the exchanges are going to pass by over time. And this is a view that we read top down. So it's working just like a sequence diagram is in your SysML language. The difference here, there's a slight difference in this view. Instead of focusing on calling operations and sending signals, you can still do that here in UAF, but it's less commonly the focus. We're typically looking just at the message exchanges. You can see on here, we're realizing these exchanges on the messages themselves. We get the same arrows that we would get on the connectivity view. We're showing in order to achieve or conduct a certain scenario, this is the order in which our messages must be sent. And we can track timing. We can say how long it takes between those messages from sending one message and maybe receiving another. We can track that timing, which is really, really good, right? If we're trying to track and be very clear about the ordering and sequencing of these messages. So that's our sequence diagram. That's in our sequence aspect. A few more, we have information aspect. This is all about your data elements. So tracking the different types of exchanges that we can pass back and forth and how they break down. So the information diagram can be at different levels of abstraction. You can have conceptual data models, logical data models, physical data models. That's up to you how you want to break those down amongst the different viewpoints. But it's information elements that we're focused on, and we can show how there's types of information. So almost like an OR situation on the left here, where if I send a message, it's one of those 3 subtypes that I'm sending. Or we can show more of an AND situation on the right, where if I send an order information, that's including drinks and food. So it's including 2 different pieces of information. And we just kind of break them down, and we show the different metrics or measurements, what we call them here, which are kind of like value properties from SysML. We show those on our information. And then when we send this information in the connectivity view or the sequence view, it carries that information with it. Next is the parameters aspect. This is all about capturing those measurements. So as I've just mentioned, a measurement is like a value property. It's a quantitative characteristic of one of our elements, our structural elements. And this one's a big one. There's a lot of views that we have in this one. They really opened it up on this one. We have first a measurements table, a typical measurements table, where we can track, really it's a table of value properties. Again, we call them measurements here in UAF, but it's showing what kinds of information do we care about tracking on each of our different structural elements. Then we can build an actual measurement table. You'll see the term typical and actual a lot here within UAF. Typical is a definition element, so it's like a block, whereas an actual is an instance. So it's a real life thing that we can observe. So in this case, if I say that my battery weight is 0.5, that means I literally weighed it, and I know for a fact it's 0.5. It's not just designed to be 0.5, it's quite literally 0.5 pounds. And you can even put dates on when that value is valid within the architecture. So if we re-weight it, looks like we on line 6 here, we re-weight it, and it was 0.55 pounds. Somehow the battery grew, an extra 0.05 pounds. But that's now the new valid weight of that particular battery. So we can see how those values can change. But this is real values, whereas the typical measurement table is just the expected value. It's the default value. So we got both we can look at. We then also have an environment diagram. The environment diagram allows us to capture the conditions or concerns that we have in which we need to operate. We can establish the environment in which an object must be able to be operable or conducted. We can define a location for where it needs to be operable. We can define a geopolitical extent type. It's just a fancy way of saying like boundaries. And we can do just general conditions like high altitude or hot weather, things like that. We can define all those different constraints here in our parameters and say these are the things that we must account for with real values. And then we can apply those to our different elements within the viewpoints to say that you must be able to conform to these and operate within these constraints. So we're just kind of tracking what's that environment look like. Then finally, we have a risk diagram. The risk diagram allows us to track just generally what are some of the risks that we're concerned about. Now, this is a new feature in 1.2. Before, in the older version of UAF, we just had security risks, so like hacking or malware, things like that were cyber concerns. This is the broad application of it, so just any risk. Here, if we're a restaurant and we have an automated order taking system, one of the risks may be non-payment. Maybe somebody's going to walk out on their bill. So we can capture that as a risk that we're taking on. We can establish who owns that risk, who's responsible for keeping track of it. We can track what's our methods for mitigating that risk, and show opportunities and systems that are being affected by that risk. So it's a nice little catch-all for doing risk assessments. And this is one that you can build not just in using the UAF language, you can also use the new ROML language, which is another standard from OMG. So it's another option that you have for these views. So that's the parameters. We have 3 more to go. We have constraints. Constraints are going to be kind of like the requirements. They're going to constrain the way in which we can operate or build the different nodes within a particular viewpoint. The main one that we're going to see in this one is a constraint table. It's a table full of rules. So what are the rules? What are the names of the rules? What are the specification for those rules? And then what kind of rule is it? You got a handful of different types of rules that you can specify. Here we've got a constraint, an assertion on your functions and action, and then guidance. But these are things that are, again, going to constrain the way in which we achieve things within that particular viewpoint. You also can have a constraints definition diagram. This is where we start to bring in things for our parametric diagrams. So the constraints definition diagram is a good place to build a BDD and define your constraint blocks if you're intending to build parametric views and do calculations. If you want to do simulation in UAF, it works the same way as it did in SysML. That's one of the big advantages that UAF has over its predecessor, UPDM. So these constraint blocks are just regular constraint blocks. They're coming from SysML. We can wire them into our viewpoints, and then we can build a parametric diagram in the same way that we build it in SysML. It sits underneath our object that we're trying to decompose, and then we wire things together, and then it allows us to do simulations for calculation. Then we get to our new feature, which is a roadmap. The roadmap is the only thing that doesn't really exist in prior iterations. All the rest of these things you could find in SysML or something akin to it. This is pretty much brand new. The roadmap allows us to look ahead or look behind us. It's temporal. So we're actually tracking time with the roadmap aspect. We're able to see how a system or a resource can evolve over time. And then we can forecast out and look ahead of ourselves to kind of see, in the future, what do we think things are going to look like? And we can kind of strive towards achieving that vision. So we have 2 different views here. There's going to be the evolution and then that forecast I just mentioned. The first is the evolution diagram, and this is a Gantt chart. So again, completely new. There are wizards in Cameo to help you build these because, again, if you've never done one, you do have to learn how to build it. But Cameo does have a bunch of wizards built into it that will help you to build these out. So they're not as bad as they sound. Some of them can be a little bit complicated, but the wizard helps walk you through it, quite honestly. Each row in an evolution diagram represents a version of your overall system that you're looking at, and the idea being that you can kind of see how that resource evolves over time. It's coming from a view where we're looking at different versions of a particular resource. So like if we're looking at like the Windows operating system, we can kind of see how it goes from early on things like Windows 95, 98, Millennium, Vista, XP, all those. As we keep going down that flow, we can kind of see when we are supporting those different versions, but it's all the same product effectively when it's all said and done. It doesn't have to have that constraint, but that's where it's coming from. And so we can identify for one particular resource, when is it deployed and when has it been end of life? When is it taken out of service? And that defines our 2 endpoints on this Gantt chart. And so you can see it's bound. In this case, we're doing it by year, but it can be as granular as days or even hours or minutes in Cameo. And then we have the forecast diagram. The forecast diagram allows us to look ahead and say for, in this case, an order taking technology, that's our general type of technology, what do we envision to be the standard within the industry in different periods looking forward? So from 2000, up to 2000, it was just a server. From 2000 to 2025, we had a standard POS and a server. Looking ahead in the next 15 years, it's going to be our new order taker 3000 that we've designed. And then in the future, we've got some super cool AI system or some omniscience engine where it just knows what you want. And we don't have to worry about it. So we're kind of expecting different technologies as we look ahead. And this allows us to, really better identify our goals and strategize as we go forward. That's the idea. And then finally, we have the traceability aspect. This is going to allow us to connect things together. So this is all about matrices in this one. So each one will have its own viewpoint specific matrix. Each one of our viewpoints has a specific one. Some of them have like 3 or 4 different viewpoint specific matrices, but they are built specifically to see connections between objects, not necessarily just in that one viewpoint. They also can cross into other viewpoints. So the example we see on the right hand side here, we have the system functions implementing the operational processes up above. And so we can see those connections. Most of these you're gonna have to build on your own. You can create the view, but then you'll have to actually fill in each one of those arrows and define them. Some of them are automated, but that's much more rare than the ones that are done for you. All right, now we're going to look at the viewpoints. So we covered all the columns. Now it's time to look at all the rows. And again, remember the columns identified what types of views we can create. That was the goal of identifying the columns. So everything we just covered, barring the black squares in each of these viewpoints, you can build that kind of view in the viewpoints. That's the idea. So now that we've learned how to build the different types of diagrams, we're going to focus now on what's the content that goes into each one of those diagrams. And it's going to depend on which row we're currently looking at. The first two are the super high level ones. This is the architecture management and our summary and overview. These are going to be the views that identify what we are trying to achieve with our enterprise architecture. It sits above the enterprise. So you can see it's above the strategic view. That's really the strategic view is where we really start our work on the enterprise. This is before that. Here we're establishing common terms. What framework are we using? Which in this case is UAF. What language are we doing? What tool are we using? Who's doing it? When do we expect it to be completed? Do we have any other assumptions or constraints that we're tied down to? Who are our major stakeholders? What are their concerns? That's the kind of information you're going to see at this high level. It's rationalizing what we want to achieve with the enterprise architecture and strategizing how this model is going to get us there. So we're not coming up with capabilities, we're not coming up with resources. It's all way before that. So that's what these two views are built for. If you have custom profiles or custom ontologies or terms, they'll be tracked up here. The dictionary for your larger system your enterprise is tracked up here. That's the kind of content you're going to see here in the architecture management and summary and overview. They kind of go hand in hand with each other. And they look like this. So the summary and overview, it's just a descriptor on top of that top level model object, that the root element in your repository is going to contain a number of different tags that you can fill in, like assumption and constraints. You can see there's an architect, there's an approval authority, a framework, a purpose, and if you load that DARS template at the bottom there are dozens of fields. I think there's like 50 or 60 fields you can fill in. It's a bunch. But you fill in what you want and what's relevant. And then the dictionary is the other big thing that you'll see out of here, which is just a tabular view that shows the descriptions for the elements that you have within your enterprise, where they're located, what types of objects they are, and often you'll see people put the diagrams that they're used in on here as well. That gets us to the strategic viewpoint. The strategic viewpoint is all about capturing the goals of our enterprise. So we start with what's driving us to what are we trying to do within our enterprise. We'll look ahead and look at the different phases of our enterprise, and temporally or structurally, and we'll say maybe for Q4 FY25, I want to be able to achieve this capability. And we'll come up with the reason for that. Why are we wanting that? What is going to prohibit us from achieving that? What hurdles do we have to cross over? Are there other capabilities that we need to achieve to get to that point? All of that captured here in the strategic views. But the overall result of this work is that we will have established what those capabilities are. That's the goal of the strategic viewpoint. What capabilities are we wanting to achieve and when are we wanting to achieve them? Because our phases are going to dictate that. So Q4 FY25 would be a phase of our enterprise and it can achieve a certain capability. We can now strive towards achieving that goal. So many views, in the strategic viewpoint that allow us to do that. We have like the motivation for opportunities and goals. We have the capability taxonomy, capability dependencies. We have a phasing diagram in the bottom right. And then a processes view here is what we use to show the temporal breakdown of our phases and which capabilities they're trying to phase. That drives us into the operational viewpoint. Now, the operational viewpoint comes next because it's going to be the place where we logically capture what processes are needed to be executed to achieve those capabilities. Remember, the capabilities are the main thing that came out of the strategic viewpoint. Now we're going to define what kind of process needs to happen so that we have that capability. And this operational viewpoint is your logical viewpoint. So we try to limit solutions in this location. Sometimes it can't be avoided, but generally we want to keep these high level and we want to keep them open-ended. If I'm Amazon, I'm trying to deliver a package from my warehouse to your front door, I'm going to capture the process of delivery from the warehouse to your door without describing how I'm going to do that. The warehouse is going to bundle up your object. That package is going to be picked up by something, don't know what, and it's going to travel, and then it's going to be deposited at your door. Now that's high level. Now, how did we do that? Well, that's going to come a little bit later. Did we get a drone to do that? Do we have an Amazon delivery driver do it? Did we pay the local kid on his bicycle to pick it up and drop it off? Don't know, right? We have different ways of which we can achieve that. Keeping things high level in the operational views gives us flexibility, and then we can look at the trade-offs of those different implementations later on down the road. So when you think operational views, think logical views. It's those business processes where we're not looking at solutions, but we're trying to define what has to happen. What do we have to do to achieve our capabilities? Major views here. We have a high level text. Yes.
Hey, Tim, real quick, just to give you a heads up, in about 9 minutes, we'll need to move to the Q&A just to make sure we have enough time for that.
Perfect. Should be good on time there. Thank you.
Awesome.
So we have the operational views that we can capture. So a high level view of our architecture. We've got the exchanges. We got the processes. All that are going to be captured here in the operational viewpoint. That takes us down to the services. Services, if you recall, is one of the ones that we had flanking on the left-hand side of our UAF picture that we saw earlier on in the presentation. Services are going to support operational concerns as well as our resource concerns. Services allow us to identify what needs to be provided, what level of service needs to be provided or required for us to achieve an activity, to perform an activity, or in order for us to integrate between two different systems. So there's flexibility in this view. We can establish what those look like with the services viewpoint. In this case, we're looking at service, they're called services, but they're accesses. And when we take an instance of those, we have a provided level and a required level. And so we can use these as intermediaries to identify what those connections need to look like, which are really, really helpful. So this is coming from the service-oriented architecture type of approach. It's not required by any stretch, but it's a good extra use of defining those connectivities. Next, we have the personnel viewpoint. Personnel viewpoint is all about the human resource. So I mentioned that the operational views is they're the logical needs. What do we need to do technology agnostic or solution agnostic to achieve a capability? Personnel and resources are our two options. Either we get a human to do it, or we get a piece of technology to do it, or some combination of the two. So you're going to see the personnel and resources really go hand in hand. They're at the same height. Personnel is just all about the HR side. So it's the human aspect. We can create our org chart in this view. We can come up with our HR processes, like how to hire, fire, provide a raise, things like that. And we can track what are the organizations and people within those organizations, because all of those people are capable of exhibiting those activities that we establish at the operational viewpoint. So the personnel domain or personnel viewpoint is all about those concerns. And one of the unique views that we have here is an availability chart. This is in the roadmap section that's in the bottom left there, where we can show specific individuals filling certain roles over time. You can kind of see who's available and maybe reallocate your resources to different positions as needed. Next, we get to the resources viewpoint. Resources viewpoint is all about the technological aspect of your solution. So if it's not human, it's technological. So the systems that we have available will be found here. Technologies, software, systems of systems, all those can be captured in the resources view. And this is all this is the location where we're really, really devoted to solving the operational needs that we established at that higher viewpoint. So this is going to be the implementation view. And your human resources will come into this. Your organizations, your persons, your positions, those also can play a part here in the resources views because they, working with technology or just by themselves, can achieve those capabilities by performing those processes. So the resources view, we already saw most of these, so we won't walk through the different views here, but the resources viewpoint is all about capturing the technological side, where the personnel was all about the human side. And once we get past that, we're really now we're kind of we're at the tail end now. So if you're thinking of UAF as like a little bell curve, we're running down the hill now because these just start getting smaller and smaller and smaller as we finish up these last few viewpoints. The first is the security viewpoint. So the security viewpoint is going to take all that good work we just did before, where we established the resource that's performing a process, that's achieving a capability. That's the narrative. Now the security is going to allow us to show any concerns that we have with that story. So is there a cyber concern that could affect that resource? Is there a well, a non-cyber threat like non-payment that we need to track? Those are the kinds of things we can track here in the security views. The security views allow us to track risks, the mitigations, like the security controls that we can use to mitigate those risks. And it can also allow us to track the process that we're going to implement to properly implement that mitigation. So if you're familiar with the RMF, the risk management framework, this is a viewpoint effectively devoted to that process, that framework. And we do follow, if you're familiar with it, steps 1, 2, and 3 of the 6 that are in the RMF framework. So identifying your concerns, identifying your assets, selecting your controls to protect your assets, and then ultimately implementing those are all a part of the UAF grid, and we will use this structure, this architecture to capture that information. And then eventually it's, put it into the real world and deploy it and manage it. That's all past, obviously, the design itself. But the other 3 we will track here. Then we have the projects. Projects viewpoint are going to be the projects that the enterprise is endeavoring to complete. These could be things like designing a new MBSE project, implementations, deployments, operations, webinars. These are different projects or tasks that we can execute for our enterprise. Usually, the idea with projects is that we're using these to develop and build new things or do new things. And so the milestones, the things that define when things happen, our timestamps, are typically managed here in the projects view. So when are we deploying a new resource? When are we taking it out of service? Are we doing a PDR or a CDR review for our design for a particular MBSE project? That can all be tracked here in the projects views. It's our project management viewpoint. That being said, it's not going to replace things like Microsoft Project. No PM is going to come into UAF and do their actual work in here, but UAF wanted to provide a spot to capture those concerns and ultimately track statuses. So you may not do the PM work here, but you can track the statuses and then have that traceability to the greater enterprise to get a better complete picture of where we are, which is really, really nice. And so here we got Gantt charts, we've got decompositions of projects or milestones, a lot of good stuff that we have in here. Last 2, we have standards. The standards viewpoint allows us to define the documents or constraints that we need to follow. And by following these standards, we can claim that we get whatever benefits come with those. If we're following a particular protocol and it's been proven to prevent certain cyber risks, then we gained that benefit. The standards viewpoint is all about capturing what are those standards and protocols that we as an enterprise care about, and then we can show which resources are conforming to those standards. So we can highlight that we are following a standards-based approach. This one's pretty tiny. We just have like the taxonomy, the structure, and then a roadmap. There's not a whole lot. This is really all you get in standards because again, as we keep going down, it gets smaller and smaller. And then finally, the actual resources. This is going to be the place where we track real deployed resources. So things that are not just designs, things that are not just templates or ideas. These are things that are really out there. So if I'm looking at my real restaurant and I've designed this order taker 3000, well, as a design, it's one object that can do a bunch of different things. But in the real world, I'll probably have one of these on every table. So I'll have I'll have maybe 20 or 30 order takers. Each one will have its own unique identifier. They'll all have different, batteries and colors and whatever else, where these are instances. So they're real, no kidding things. And when we look at all the real deployed resources, we can start to use them to do different scenarios, and we can focus on the real, no kidding objects and see how they work within the enterprise. So this is a place where we can do low-level simulation, low-level testing or trade studies to see not just as a design, but just for the things that are already out there, that are already really in our enterprise, how can we utilize those in the best way possible? And these, again, just are showing their instances. So they're just showing those breakdown of those resources and how what they can do with each other. And that's the grid. That's UAF as a whole. There's one other thing I want to cover, and then we'll open up the floor for questions. That's the fit for purpose views. If anything doesn't naturally fall into that UAF grid, it's considered a fit for purpose view. These fit for purpose views allow users to build non-UAF standard diagrams. Maybe you're joining different views like a taxonomy and a structure, and you want to see both in one view. By all means, if you want to see operational objects and the implemented resources objects in one view, fantastic. That's what these are for. So we call these all fit for purpose views. We can also do other things like generic tables or matrices, these other analytics that come with Cameo. You can use those as well. They're also considered fit for purpose. But don't be the big thing with this is that don't feel like you are limited to what's in UAF. Even if there is a lot, you will likely run into places where you want to build your own view, which is it may not properly fit. You would create them in a fit for purpose view in that case. And that's all we got. That is the overview of UAF and enterprise architectures. I hope that was informative. I hope you guys were able to learn new things from that. But with that, we will open up the floor for questions. David, do we have anything in the Q&A section?
Yeah, we do. Lewis gets a golden star for some three great questions that he's got. So I'll go in the order in which they were submitted. So first he asks, is there any relationship between UAF version 1.3 and SysML 2.0?
Good question. So not per se, no. So SysML v2 is that's the new hotness for MBSE, and that should be coming out later in this year. The UAF is intending to migrate to a SysML v2 underbelly, but that's going to be with the official UAF v2 version. So 1.3 will still be based on the SysML 1.7, whatever version we're currently on, in UML. It'll still be rooted in that same basic setup. But talking with those that are building out these frameworks, the intention is that the version 2 of UAF will use SysML v2.
Perfect. All right. His next question was, is there a way to tie requirements to a project directly? And the context is, since a project can capture milestones and costs, etc., we are sometimes asked to show how much do a set of requirements cost.
Interesting. So we can track properties on requirements. So if there is a cost, associated to a requirement, that is something you could track. And you can do that in a requirements project. You can do that in just your enterprise architecture project, or even in a solution architecture project like in SysML. Those are things that you can track on top of requirements. How you want to calculate those and rationalize those, that it would probably take some queries to do something like that in Cameo. Most of the time people are putting those kinds of fields on top of a system or a resource, and then they're summing them up that way. But yes, you could do those on requirements.
Awesome. Thank you. And the final question. I realize that in Cameo, in order to build a roadmap, you must first have to create a timeline element. You can have multiple timelines. Can you explain what is the purpose of multiple timelines and how to properly build it so they can be properly used across your architecture?
Yeah, that comes up a lot. So a timeline is an object in UAF that holds timestamps or milestones, more appropriately. Milestones are the important timestamps that you have within your enterprise architecture. So when you build a roadmap, it will ask you what timeline do you want to put this on. In fact, anytime you build a milestone, and just in general, it asks you what timeline it goes on. There is one built in, so any UAF project you build, Cameo will automatically give you a timeline object associated to that project, so you can just use that default permanently. You don't have to create additional ones. The idea, though, is that you can come up with alternative futures and say, I have one timeline, the sacred timeline, if you will, where we can look ahead and we can say, this is what I expect to be based on our decision makings, based on our what we're building out. This is what I think, all of our milestones are going to be. But then you can do more what if scenarios, and you can create a new timeline object, and you can put a different set of milestones on that other timeline. And the timelines really are just a way of managing your different milestones. If I'm in this timeline, maybe my milestones are all a year off compared to the original timeline. So they allow you to do better what ifs. I don't see that used very commonly. That's a very rare thing that I see teams using that, but that's what it's built for.
Awesome. And Lewis, with the four in a row here, one more question: can a dictionary function like a glossary table, where one hovers over the word anywhere in the model and it provides the definition?
Sadly, no. In Cameo, a glossary table is very particular. You have to have a term with its definition. You can have one of those in the dictionary in UAF. In fact, that's pretty common, and that's actually a thing I like to do, is have a glossary table in that dictionary section that would allow you to then use the terms, like you talked about. You'd see the underline, and you can hover over it. But the basic UAF dictionary, no, it would not function that way.
Thank you. Lewis, if you would like, if you just raise your hand, or you can put it in the chat or wherever, if you'd like a moment just I could unmic you if you have any other questions, because you had some really awesome questions here. And if not, no worries. I do want to also say if anybody else has any questions. Perfect. I wanted to make sure that Tim's answers also hit the mark for you and that you didn't have any follow-ups to those. Wonderful. Does anyone else have any questions or even thoughts that they want to share with the group? Any experiences working in UAF so far? Love to open it up on the floor. We'll wait another minute or two to see if anyone has anything. Otherwise, we can take just a minute to wrap up. So
Yeah, I'll let you,
looks like,
if Dave, if you want to display the contact page, just in case you guys want to reach out.
yeah, one moment. Carla, thank you for that feedback as well. Glad you could make it. All right, here's the contact page. So again, we are Enola Technologies. You can reach us at www.enola.com or sales@enolatech.com. Please, if you didn't find this via LinkedIn and you got this link to register somewhere else, please start following us there. We are expecting to have we're going to try and do a webinar a month. Next month, we're still coordinating, but it looks like Saulius Pavolkas from Dassault, who is the director of their ecosystem in MBSE, will join us. I think we'll be talking about SysML v2, but we'll nail down the details and send that out. I see some more questions coming in real quick, so let me address those. Dan, the recording, I don't know exactly how long it takes for Teams, but I'm going to try and get this out for you and everyone else today, if at all possible. Worst case, tomorrow. So I think it just takes a minute to compile the transcript and everything. And then, Lewis, yes, we'll work on getting you copies of not only our overview slides that I presented, but of course, the real presentation that Tim presented to make sure that everyone that attended has that shareable. It may be a little bit large, so it may be sent out as a link. If anyone has any problems receiving with how we send out due to file size or security limits, please just ping us either on LinkedIn or again at our email, and I will work to get that to you individually. Thank you for the feedback, Dan. Okay. Well, Tim and I can just kind of hang out for the next few minutes, but if anybody has any other questions, we're here. Otherwise, everyone, thank you so much for your time, for your attention. Tim, thank you so much for that really great overview on demystifying UAF and everything that it encompasses. And again, look for more webinars coming up very shortly. All the attendees, when we send out everything, I'll also make sure to keep you notified of future webinars on different topics of interest. And again, start following us on LinkedIn if you haven't. We love to get your feedback from the community. We'll be asking for, content ideas, and that way we can go out and do more webinars because our goal is to make sure that we utilize your time as valuably as possible, and really providing great content that is helpful for you in your day-to-day and your careers. So again, we'll be here for a few more minutes. No one's being kicked out, but if you need to drop, have a great rest of the week and look for those follow-ups here from us shortly. Looks like Lewis has one raised his hand here. Lewis, we're down to just a couple people, so I'm gonna just unmute you real quick, and we can just have a dialogue. Allow mic. Lewis, you there?
It's still showing as
now.
muted.
There we go. It may be. I think it was muted on your end.
All right, no problem. So I guess it may be more of a specific implementation, but I'm trying to build a architecture in UAF where it's almost like an architecture for an environment, specifically a training environment, and I'm trying to connect multiple training devices that some have already existing SysML models, others don't. But I would like to be able to connect those. What would your recommendation be to if I wanted to connect other SysML models into a UAF architecture?
Yeah, that's a good question. So that in UAF, we tend to treat those SysML models as a black box. And so your training software, we'll say your training application, would have its own node as a resource in UAF. Now that could be backed up by a whole systems model. You could actually bring in, if you wanted to, as a project usage, your SysML model into this one. And then whatever that top level block is, you would bring in to your UAF project. A lot of times, though, that bloats the model. That brings in a lot of unnecessary connections that you don't need to show, especially when teams have a lot of these. And so generally what you'll see is just like I said, a black box implementation of that resource. It'll have a name, it'll have perhaps major subsystems, but it'll focus on the interfaces, the metrics, and the behaviors, and then we'll show that.
Yeah, because what I'm thinking is if I can create a environment, or model my environment as like a resource, and I will create, I guess, abstracts, either systems or resources, software, with I don't want to get into the details because every training system may be unique, but create almost abstracts of those that represent the different platforms, if you will, or different missions or mission nodes, and then and assigned capabilities, or in the form of either operations or whatnot, as a resource, but then the individual training platforms can come in, project usage, the training environment, and say, hey, I want to be able to pick, let's say I'm, a training system for platform A, and I may have 12 different implementations at different levels of fidelity. I can just pick my system A abstract and say, well, implementation 1 can satisfy 8 of my 12, and basically, leave it as an abstract without necessarily defining a solution, and having the platforms being able to project usage at this my model, but at the same time, on top of that, maybe there's like an analysis. The project usage is everything, and so that we can see for a particular, now when we maybe we're looking somewhere else, we're building, training sites, or maybe we're representing a particular base or a particular site and saying this site will have this specific type of trainer, which represents this abstract and connects to the environment. It may be a very specific what I'm trying to do, but it's kind of like, that's kind of where I'm thinking. And my thought was, maybe, I originally wanted to do it in SysML because it's the most basic and everybody knows how to use it. But
yeah,
I think what I'm going is, I'm leaning towards UAF because it encompasses a lot more, and it's more built for what I'm trying to do, because it captures the enterprise, not just a particular system, if you will.
Yeah, and actually, you make a good point there, right? Is that everything we talked about today could be done in SysML, right? There's no reason that you have to use UAF to achieve the same thing. But UAF is built to give you a lot of those types of elements that you don't have to conceive of on your own in SysML. Not everything has to be a block. And so for your use case, yeah, UAF does sound like a good solution for it, where you can capture the resource concerns, the operational concerns, the personnel, right, that would fill in those training departments, as well as some of the environments, right, that they must operate in. Those are the kinds of things that UAF just gives to you. So it probably would make a little bit more sense. I would definitely agree that leaning towards UAF makes more sense for that use case.
Okay. I appreciate your time, guys.
Absolutely.
And say hi to Dave Fields for me. I used to work with him back in the day, so.
We'll definitely do that. We'll definitely
All
do. I'm sure he'll love that.
right.
Thank you
Thanks,
for
man.
attending, and thanks for the great questions.
All right. Thank you. Bye.
Thank you,
Thank
Louis.
you.
All right. Well, we'll go ahead and close our event. Dan and Matt still on. Again, appreciate your time. Hope you got a lot out of it, and look for our follow-ups shortly. Thank you, Tim.
Thank you.